Let's do a couple of warm-up problems, converting fractions to percentages, and then converting percentages to fractions. And then we can do some actual word problems. So as our first warm-up, let's convert 5/24 to a percentage. And the way I like to do it, I like to convert it to a decimal first. And once you have it in a decimal form, it's pretty straightforward to convert it to a percentage. So the way you convert it to a decimal is you divide the denominator into the numerator. This can literally be read as 5 divided by 24. So let's do a little bit of division. 24 goes into 5. And we're going to have to add some extra spaces to the 5, because obviously this is going to be less than 1. 24 is a larger number than 5. So let's put our decimal right there. And we can now do some division. 24 goes into 5 0 times. 0 times 24 is 0. 5 minus 0 is 5. Bring down this 0 right here. 24 goes into 50. Well, it goes into that 2 times. All right, 2 times 24 is 2 times 4 is 8. 2 times 2 is 4. Now we subtract. 50 minus 48 is 2. Bring down another 0. We're going to keep bringing down zeros until we have no remainder. So bring down another 0. 24 goes into 20 0 times. 0 times 24 is 0. 20 minus 0 is 20. Let's bring down another 0. Let's bring down another 0. 24 goes into 200. 24 goes into 200. Let's see, 8 times? Maybe 9 times? It's 180. No, it'll be 8 times, I believe. Let's see if 8 times works. There's always a little bit of an art to this. If this is too little, we might have to increase it. 8 times 4 is 32. 32. 8 times 2 is 16. Plus 3 is 19. Now that was right, 8 times. 200 minus 192, that's 8. That is 8. Bring down another 0. Bring down another 0. 24 goes into 80 3 times. Can't be 4 times. 3 times. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Add 1, 70. And then you have another 80. You bring down another 0. We have an infinite supply of zeros here as we need them. And we're going to have another 80. Well, once again, 24 is going to go to that 3 times. And we're going to start repeating these 3's over and over and over again. So 5 over 24. Let me write this down. 5 over 24. I want you to understand why it keeps repeating. Every time we do this now, we're going to get a 3 and come down, get a 72. 80 from 72, we're going to get another 80. And we're just going to have a big string of 3's there. So 5 divided by 24 is 0.2083 repeating. Now, if we want to write this as a percentage, the word percentage, the word percent, let me split it up. Percent. Cent comes from the word for hundred. This is per hundred. So what is this? This is 0.20. What is this per hundred, where 100 is a whole? And that might confuse you or might not. One way you could view this is the same thing as, you could view it as this way. This is the same thing. This decimal, 0.2083 repeating, is the same thing as 20.83 repeating over 100. This is how many we have per 100, percent. Or you could say that this is equal to 20.83 repeating percent per 100. These are equivalent. A very quick way to think about how to go from decimals to percent is you can multiply by 100 and then put the percentage sign. Or if you go backwards, you divide by 100 and get rid of the percentage sign. That was a good warm-up. Let's do one more. Let's convert a percentage into a fraction. I'll do it in blue. So let's say we have 16%. 16%. Remember, this means 16 per 100. So this is the same thing as 16 per 100. That's what percent. Century is 100 years. There are 100 cents in a dollar. So 16 over 100, put that in the lowest cut. Let's see, we can divide the numerator and the denominator by 4. we get 4 over 25. So that's our warm-up. Let's do some actual problems now. All right, they tell us a TV is advertised on sale. It is 35% off and has a new price of $195. What was the pre-sale price? So if X is the pre-sale, X is the pre-sale price. When you take 35% off of that, it has a new price of $195. So X minus 35% of X, 0.35 is the same thing as 35%. So if I take X and I subtract 35% of X from X, I'm going to get $195. That's what that is telling me. So now we just solve for X. So you can view this as 1x. 1x minus 0.35x, that will be 0.65x. So this is 0.65x, right? If you add 0.65 to 0.35, you get 1, right? 1 minus 0.35 is 0.65x is equal to 195. And now you can divide both sides of this equation. And actually, I like to do it more as a fraction. So let me write it that way. So if you have 65 over 100x is equal to 195. Now we can multiply both sides of this equation by the inverse. Actually, even before I do that, let me simplify this fraction. I can divide the numerator and the denominator by 5. And this becomes 13 over 20. So we get 13 over 20x is equal to 195. And now we can multiply both sides by the inverse of this. So 20 over 13 times that is equal to 195 times 20 over 13. These cancel out, and we get x is equal to 195 times 20 over 13, which we could figure out, but I'll take the calculator out for this one. So you see, you get 195 times 20 divided by 13 is equal to $300. I should have done that on. So this is equal to, that right there is equal to $300. So 195 is actually divisible by 13. Oh, I should have been able to do that without a calculator. Anyway, so the original price was $300. You take 35% of $300, which is $105, and you will be left with $195. So that was our original price. Let's do another one. An employee at a store is currently paid $9.50 per hour. If she works a full year, she gets a 12% pay raise. What will be her new hourly rate after the raise? So today she makes $9.50. If she works for 12 years, she'll make $9.50 plus 12%. Plus, let me write it this way, plus 12% times $9.50. That's how much her raise will be. So her new hourly wage will be this entire thing. Well, we could view it this way. This is the same thing as 950 plus 0.12 times 950. This is the same thing as 1 times 950 times 0.12 times 950. So this is the same thing as 1.12. I'm just adding that. Let me do this in a different color. I'm just adding that and that to get that, times 950. We are growing 950 by 12%. You already have the 950 plus another 12%. It's 1.12 times 950 is going to be equal to our new number. And let me multiply this out. Just to make up for me using the calculator the last time. So 950 times 112. 2 times 0 is 0. 2 times 5 is 10. 2 times 9 is 18. Plus 1 is 19. And it'll put a 0 here. 1 times 0 is 0. 1 times 5 is 5. 1 times 9 is 9. Let's put 2 zeros here. 1 times 0 is 0. 1 times 5 is 5. 1 times 9 is 9. And now we can add. The zeros add up to 0. Zeros add up to 0. 9 plus 5 is 14. 2 plus 9 is 11 plus 5 is 16. 16. 1 plus 9 is 10. And then we count the number of decimal. We have 1, 2, 3, 4 numbers behind the decimal. So in our answer, we have to have 1, 2, 3, 4 numbers behind the decimal. So her new salary will be $10.64 per hour. $10.64. You don't have to write those trailing zeros right there. So this is her new hourly rate after the raise. All right, let's do one more. One more. Store A and Store B both sell bikes and both buy bikes from the same supplier at the same price. Store A has a 40% markup. Store A has a 40% markup. That means whatever they buy the bike for, they sell it for 40% above that. While Store B has a 250%. Store B has a 250% markup. Store B has a permanent sale and always will sell at 60% off those prices. Which store has a better deal? So let's say that they're both buying the bike. So let's x is equal to the price from supplier. Price from supplier. So that's the price that both bike stores buy their bicycles at, right? They both buy bikes from the supplier at the same price. That's this x that I'm going to start off with. Now let's do the scenario of Store A. What does Store A sell their bike for? They sell the bike for x plus 40% of x, plus 40% of x, which is equal to 1.4 times x. That's how much Store A sells their bike for. Now, Store B is a little bit more interesting. Store B, so they have a 250% markup. So they claim to sell their bike for x plus 250%. That's the same thing as 2.5 times x. 100% markup would literally mean another x. This is 250%. As we said, you can just divide by 100. You get 2.5. Get rid of the percentage sign. So they sell at x plus 2.5x, which is equal to 3.5x. That's kind of their ticket price. But then they sell at a 60% off those prices. So then they take 60% off of this price right here. So the real selling price is going to be 3.5 times the price from the supplier minus 0.6, minus 0.6, minus 60% of this price of 3.5x. And we could view this as 1 times 3.5x minus 0.6 times 3.5x. And that's the same thing as 1 minus 0.6 times 3.5x. This is going to be 0.4. This is 0.4. So if you're taking 60% off, it's equivalent of selling it at 40% of the ticket price. That's what we're doing right there. You might eventually do this in your head. Immediately say, oh, 60% off is the same thing as selling at 40% or selling at 0.4 of the price. 5x. And let's multiply that out. So if we take 3.5 times 0.4, 4 times 5 is 20. 4 times 3 is 12, plus 2 is 14. And we have 2 numbers behind the decimal spot. 2 numbers, 1, 2. 1.4. So they're going to sell it at 1.4x. So in either store, you're actually going to pay the same price. Let's say they buy the bikes from the supplier at $100. Then in Store A, you're going to pay $140 for that bike. And in Store B, you're going to spend $140 for that bike. But in Store B, you think you're getting 60% off.